Good afternoon, everyone. Welcome back after lunch. This is the first of the afternoon sessions. We're going to be listening to Miguel giving us a talk about doing RESTful web services with Flask.
Thank you. Thank you for coming. So before I start, in case you don't know me, here's a little bit of background information on myself. About 2 years ago, I wrote my blog engine in Flask from scratch. And then in these 2 years, I wrote a few articles on it about Flask. You may have heard about the mega tutorial, or maybe the 4 or so articles on APIs I wrote. I have a bunch of extensions also for Flask. These are the 5 that I'm most proud of, so feel free to check them out. And last but not least, I wrote the O'Reilly book on Flask, which it's going to be in bookstores pretty soon. So another preliminary slide. All the stuff that I'm going to show today exists in a GitHub project. It's all working code that runs. Bookmark that address. And after the talk, if you're interested, you're welcome to play with the API that I'm going to present here. There are very detailed instructions in the README file. So even if you are a beginner, you should be able to run this. Now, for those of you that have no idea what Flask is, this is the only beginner slide I have. This is basically the 7-line hello world from the Flask official documentation. The first 2 lines create an application. The bottom 2 lines run it. The middle stuff is where the important things go on. And as you can see, there's a decorated function. App.route tells Flask that the function that follows is the handler for the root URL that you can see represented as a slash. So Flask knows that when a client requests the root URL, it needs to call this function. And then it collects the return value of the function and sends that to the client as the response. And if you understand this, I think you understand most of what Flask is, because it doesn't have much more than this. Okay? If you run this as a script on your server, then you connect with a web browser, and you will see hello world in your browser window. That's it. So okay, so let's start with the good stuff. RESTful APIs. So I'm going to show the few basic API methods and how I implement them. Note that I say how I implement them. It's not the only way. Flask is all about freedom and choice, so anything you don't like about how I do things, you should improve it and let me know, so I learn too. So okay, for this example, I have a system that keeps track of students and classes and students registered to classes. So that's the example that I'm going to follow through in all the examples. So I have a route that gets the list of students. This is a GET request. My URL is /students/. I want to end in a slash. This is optional, but I want to look like a folder because it returns a collection. So how I implement this? Let's look at the 1 line in this function from the right. First of all, I talk to my database. And for this, I'm using Flask SQL Alchemy. Again, that's my preference. You can use whatever you want. But using Flask SQL Alchemy, I get all my students. And then for each student, I ask the student to give me its URL. So that ends up being a list of URLs. I put that in a dictionary with the key name URLs. And then that dictionary gets JSONified. This is a Flask helper function that converts a dictionary to JSON format as a string. And then that's the response. That's what the client gets, a list of URLs. So the client knows only a few top-level URLs. It knows how to get the list of students, how to get the list of classes, and so on, but it doesn't know much more than that. But now the client asked for the list of students, and now it's got a few new URLs that it didn't know about before. So a single student can be obtained with this route. And for this one, since I need to have a unique URL per student, I have a dynamic component in my route, which you can see with the angle brackets. So I say that my URL for a student is /students/ and then the numeric ID. This is my primary key in my database. And that is my choice. I chose to do it this way. And I say that this is going to be a handler for a get, like the previous one. And the implementation is very simple. I just talk to my database to get the student from the ID, which Flask nicely send as an argument to my function. And if the ID turns out to be invalid, Flask SQL Alchemy will send a 404 back to the client. I don't need to worry about that. And this is a theme that I'm going to repeat a lot in this session. My routes are very clean. I try not to do silly error checks that really make the code kind of dirty. So I let lower level code handle my errors. I don't do it here. So if S gets assigned, that means that the student exists and it's known. And then in the next line, I tell the student, which is one of my database models, to convert itself to JSON, and that returns a Python dictionary, which then gets JSONified. And now the client has the student. So in some cases, collections are not global collections of things. There are specific collections that apply to single resources. So an example of that would be the list of classes a student is taking. So for that, you build a URL that has the uniqueness. So I need to include my student ID, but I also need to make sure it looks like a collection, because that's what it is. So I append a final component that tells me that this is a collection, registrations, and I end it with a slash. So implementation is also very simple, pretty similar to the big collection of students that we did before. The difference is that I get my collection from a relationship in my database. So I have my student, and then I say s.registrations, and that's wired to be the relationship in my database. And then from that, I get the URLs into a list, and that list gets into the dictionary of URLs, and that gets JSONified, and off it goes to the client. So this is a post request. The RESTful principles say that when you need to create a request, the client needs to send the request as a post to the collection URL. So that goes to students, the generic URL. And the way I do this is I create an empty student, and then I call another method that I have in there from JSON. This is the reverse of the toJSON that I showed before. So this guy takes the JSON from Flask. Flask gives me that in request.json. That comes in the form of a Python dictionary. And then the student imports itself from that dictionary. Then I write it to the database. Those are the two lines that follow with the session. That's how you write something with Flask SQL Alchemy. And then I need to return a response. And the response needs to be code 201. That means that the resource was created and it was successful. I don't have anything to return, so I just JSONify an empty dictionary. I set the status code to 201, and then I give the client the URL of the new resource in a location header. And now the client has this new URL, and it can work with it. So the last two are kind of a rehash of what we've seen so far. This is to update a resource. In this case, you send the client sends a put request, and it sends the fields of the student as JSON in the request. And what I do here is I load my student, I call from JSON to update its properties, I write it back to the database, and I return an empty response because there's nothing to say. It worked. And this is the delete case, which is even simpler. I just load my student, I tell Flask SQL Alchemy to delete it, and I'm done. So let's look at all these helper methods that I'm using to make my routes very beautiful. So at the top, you can see get URL. I'm not hard-coding my URLs. That's bad. Flask knows what all the URLs in my API are. So I can tell Flask to generate the URL for me. And for that, I give it the name of the function that handles that URL, which is getStudent. And I give it any arguments that the URL needs. And I request that the URL be external. That means that I want the scheme and the host name, all of that in the URL. It's a fully qualified URL. The toJSON is the method that returns the JSON representation for my student. And for this, I just return a dictionary, and then I build it right there. I just I put the URL in it. This is a reference to itself, so that when the client keeps that resource somewhere, it has a reference to where it came from. This is a simple API, so I have a name. That's the only thing I have for a student. And this is very important. I return a link to how to obtain registrations for that student. The client doesn't know this until I tell it how to do it. It's very important that I don't tell more than I need to the client, because I want to reserve my right to change my URLs as much as possible. So the client needs to know only top-level URLs. I document only those. And of course, I use URL4 to also generate my registrations URL. So this is the reverse of the toJSON, the from JSON. So I said before that I don't want to handle errors in my top-level or high-level code. And here I need to do it. And the way I do it is by throwing exceptions when there's an error. So I just put my the code that copies all the properties from the JSON into my model inside a try block. And if there's a key error, that means that the client didn't send all the information it needed to send. And in that case, there's going to be an exception. I don't throw the key error exception that Python throws. I just throw my own validation error. And I include a helpful message with it, so that the client knows what happened. Which brings the topic of error handling. So if I just do what I just did in the previous slide, then Flask will stop. It'll find an exception. It will not know how to handle it, so it'll return a 500 error to the client. But I don't want that. So what I do is I create handlers for all my errors. If you look at the bottom two of those 4 functions, those use a decorator from Flask called error handler. These are 2 modes in which you can catch errors. The first of the 2 takes a custom exception. That's my JSON validation error. The second one takes an error status code. So you can catch errors both ways, and then you can handle them your own way. And my own way is to call a wrapper function that generates an error response that has all the information, including the message that was generated when the error happened. Unit testing. This is very important. Flask comes with a unit testing client. It's a generic client that is not made specifically for APIs. So if you use it as is, there's a little bit of boilerplate code that you need to do. You need to tell it that you're working with JSON, convert the JSON to strings, and it's kind of kind of annoying to do that a lot, and I don't like to repeat myself. So I subclassed the Flask test client, and I have a much more friendly API test client that I can use in my tests. And if you see in this example, I have my client as self-client in my unit test class, and I just say post to create a resource that sends a post request. I pass the URL, and I give you the data as a Python dictionary. So we're going to create Susan here. And then if that request went through, I get the response object from Flask, that's RV, response value. And I also get the decoded JSON as a dictionary in case I need to check stuff that came with the response. So in this case, I make sure that the route returned to a 1, and then I capture my location URL. Now I know where Susan lives. So I can continue on my test and now ask the API to give me Susan. And I can make sure that that returned 200 and that the name is Susan and that the URL is the URL, the correct URL. And you can keep going like this, and if you look at the GitHub example, you'll see lots of tests like this. They're very readable, very, in my opinion, very beautiful. So this was simple. So if you thought that was not simple, then you can leave now, because now it's going to get really, really crazy. So this is very important. Unless you are doing a small API project that you're running inside your home, you should authenticate your APIs. You never want to leave an API open to anyone. So we're going to look at that. And for this, initially I used to write my own code like I always do. But I found that specifically for authentication, there are a number of things that you always need to do, that they're the same for every project. So I ended up writing Flask HTTP auth. This is an extension that it's very simple. It just takes care of handling the HTTP headers for me. So all you need to do is provide a function that verifies that the username and password are good or bad, and decorate it with my decorator. This extension provides this decorator. So the function gets the username and the password. It loads the username, and then presumably your user knows. Oh, did I say user? Yes. The user knows how to validate a password, so I just ask the model to tell me if the password is correct, and the function will return true if it is. If I return false from here, the extension will not let the request through. It will return a 401 instead. So how does this work? You need to tell the extension which routes you need to be password protected. You may not want all of them protected. And I'm repeating myself here, but that is done with a decorator. So you just decorate the function, and as you can see, you can have multiple decorators in a function in order. So you decorate the function, and that's it. That's all you need to do. The body of the function didn't change. That's identical to what it was before. But now I know that if the client doesn't provide the correct credentials, this is not going to run. So it may be repetitive to say, login required on every route of your API if you have a large API, and more often than not, you want to protect all your API endpoints with passwords. So one little trick that you can use in that case is to set up a before request handler. This is a Flask feature. You can set up, again with a decorator, a function that is called before any requests are called. So this is one function that gets called for any requests, regardless of where it goes, what function then needs to run. So this is one place where you can do common work that applies to all your API. And what I do here is I stick my own decorator. So I decorate this instead of the routes. So then I don't need to decorate any other routes. Now, Some people don't like to send usernames and passwords constantly. It can be seen as a security risk, even though you should be using secure HTTP. The fact that the client needs to handle the passwords and the server needs to handle the passwords could mean some sort of risk. So the traditional way to do this is to not use the password, use an authentication token, and you can decide what the tokens are. You can make them expirable, you can make them permanent, you can make them revocable. There are many ways to do this, and I have one implementation in the source code that you can check out. But essentially, I just replace my verified password handler for Flask HTTP auth with a function that verifies the token. That's it. In this case, I'm passing the token as username in the HTTP authentication headers, and I don't use the password. The password is unused, can be empty. So that's authentication. That was fun, but that means you're using someone else's decorators, and it's my decorators, but for you, I'm someone else. What I think the real power of Flask is when you design your own decorators for your API that are specific to your cases. So all the examples that I showed end with return JSONify, right? And sometimes I even say to JSON to the object that then I JSONify. So that's kind of repetitive. I don't need to see that in my routes. So how about this? I just decorate my routes with JSON. And then I can return a dictionary. That's the top case. This is an example I didn't show before. It returns the authentication token. So I just return the dictionary. Don't worry about JSON. And then the second example I've shown before, I don't even convert it to JSON. I just return an object, a model. And you may be thinking, yeah, but the decorator must be ugly, long, difficult. And this is the decorator. That's all you need to do. So when you write a Python decorator, you have a small amount of boilerplate. I'm not going to go on that. I can claim that I remember exactly what those things, the 3 lines at the top, are, but I just copy them from decorator one to the next, and they work. The important thing is the body. This is the code that will run as a wrapper before your function runs, when you have the function decorator. And in this context, the original function is f. So this wrapper can call f at any time. So what I do here is I call f, that's my original function, and then if I don't get a dictionary, then I've got a model. So I call to JSON. Now I have a dictionary. So what I do is I JSONify it, and I'm done. But that was too simple. We need to do some more fun stuff. So one important thing when we have an API in the open is to make sure that clients don't abuse it. And one way is to limit the rate at which clients can make calls into it. So how about this? I decorate any route that I want, and I give it a limited number of tries and an interval. So in this example, this route can be called up to 5 times per 15-second period. Everything else the same. I didn't change any other thing, just put the decorator. Now, if you have an API that you want to rate limit globally, so you want all the endpoints in your API to be rate limited together, then we can, I'm not showing this here, but you can use the same before request trick that I showed for authentication. Just decorate the before request. You rate limit that one, and that will prevent the whole API to be accessed more than what you want. And this is the implementation. It's still not that terrible. Worse things will come in future slides. I'm using a helper class. I don't want to mix things. So The rate limiting functionality is in a class. It's called rate limit. And the implementation is in the source code if you want to learn how to do this. It uses Redis as storage. There are many other ways to do it. There are even packages that do this, so you don't need to use my implementation if you don't like it. But anyway, this works by assigning a unique key to the function that it's getting called, which is f.name, and the IP address of the client, which Flask gives me as remote address. So that's my unique key, and I give it to my rate limiter. And if the rate limiter says yes, I then call f, which is my original function. If the limiter says that this client is over the limit, I send a too many requests error. So I could have said here abort 429. That's the HTTP code for too many requests. But remember that I said that I prefer to wrap all my errors with helper functions. And when you see this, you understand what it means. If I said, abort 429, you'll have to go look up what that means. So this is better. Pagination. So all the examples I've shown, I just get all the elements in my collections and return them. That could be a burden for the client and the server. Maybe the client has a very small screen. It can display only 5 students at a time, so why give it 1,000, right, if that's the size? And same thing for the server. It may be an expensive query to get 1,000, and if the client wants 5, then I should give him 5. So that's it. This function, when it's decorated with my Paginate Decorator, needs to return a database query that's still to be run. This is a query that's ready to run but hasn't run yet. In this case, I'm returning the query from my relationship. And this is the way the response looks. So this is what the client will receive. At the very top, you can see the URLs list of registration URLs. And then the decorator inserts a second key in this response. It's called meta. And in it, there's a list of things that are useful for clients that want to build pagination buttons or links. So I give it the page number, items per page, total number of items, total number of pages. I don't have a previous link because this is page 1, so it knows that there's no previous. There's a next, a first, and a last. And this is how it's implemented. So just to make sure that you understand this, I'm going to separate this in 3 parts. This is the middle part. This is when I run the original function that returns the query. When I get the query, I paginate it. This is a feature of Flask SQL Alchemy. That's very nice. You can give it a page number and a page size, and it returns a pagination object that has a lot of useful information for building the links, in addition to the items themselves. So page and per page come from the query string of the URL. So above the query lines, you can see that I get query string variables page and per page, which I can get from Flask. Flask request object, request.args has that's a dictionary with all the query string arguments. And I have to make sure that I use defaults if those are not present, because the client doesn't know about these. So the first time it asks about this collection, it's not going to send any pagination links. It will just say, give me all, and I'm not going to give it all. I'm going to give it, in this case, the first 10. Below the paginate call is where I build that meta dictionary with all the links. And I'm using URL4 to build all the links. I mean, it's a few lines of code, but there's nothing really, no rocket science there. I just build a dictionary, and then at the bottom I return the JSONified, version of that dictionary with the two keys, the URLs and the meta. Caching. So I thought long about a good example to show for this, and I decided to go with a no cache example. So I have a route that returns authentication tokens, and I want to make sure that the client does not cache that because it's sensitive. So how about I say it like this. By having this decorator, the response will be enhanced with a cache control header that will tell the client to not cache this, to throw it away. And this is how it's implemented. For this, I decided to implement a decorator that it's a generic version of the cache control. That's at the top. This one takes a list of cache control directives, and it just sticks them in the response. And that's this. I just make a response object from the response returned by the original function, and just then add the cache control. And then for the no cache specifically, you can see that at the bottom. I just create an instance of the other decorator with the specifics. Those three keys that, or directives that mean do not cache this. But that's not all you can do with caching. The nice thing, when you follow the RESTful principles, more or less to the dot, then you get caching, advanced caching for free. If you have responses that are useful if the client can cache, then you can save a lot on bandwidth. So, for example, if the client has a response that is in the cache, the client can ask the server if that response is still valid, and if the server says yes, then there's no need to transfer that response over the network again. One of the mechanisms that the HTTP protocol uses for this, it's called entity tags, ETags, and this is how I do it. The only change. So look at how beautiful this, I still marvel at how concise and beautiful this route is. Right? You can read it and you understand everything it does. So the ETag does a couple of things. It generates an entity tag. An entity tag is basically a code that represents that version of that request. That resource. And when the resource changes, you have to change the tag. And if the resource doesn't change, you keep the same tag. That's it. The client caches the response, and it remembers the tag, and then it can ask the server if that tag is still, valid. So this is the implementation. This is the last one, so I'm almost done. I'm not going to go, in detail, but if you understand how the HTTP conditional requests work, this is the if match, the if non match headers in the request, then this is hopefully going to be very simple for you to understand. The entity tags that I generate, you can see somewhere in the middle there, right after make response, are pretty generic. I just take the JSON text and I get an MD5 hash. This is, you could say this is expensive. This is very generic. It will work with anything. Of course, for a specific application, you can have more efficient entity tags. Depends, and that's basically that's all I have. Thank you. Okay, So yes, if there are any questions, you need to use the microphone that's in the middle. I left everyone confused. Great. There's a question.
Hi.
Hi.
So I was just wondering, what do you think it's best when you get input for creating a resource? Will it be JSON in the post body, or will it be like key values, or?
So it's your choice. The RESTful principles don't say how it needs to be done. I think JSON is it's good. It's definitely helpful for the client, because if the client is JavaScript, it's kind of native for the client, and yeah, it has to be in the body. So definitely in the body, not everywhere else. It can be XML if you prefer that over JSON. But yeah, it's key values as JSON. That would be my preference.
Thank you.
Yep.
Hi, two questions. My first question is about your extension on HTTP authentication.
Mm-hmm.
I was wondering, does your plugin support digest authentication? And if it does not, then I swear, next weekend I'm sending you a pull request. Because right now...
I saved you some time because it does.
It does?
Yes,
oh,
it does.
You are my best man right now.
So yeah, check it out. The way you use it is a little bit different. So you don't do what I showed here. It's slightly different, but it's in the docs, so check it out.
Okay, and my second question is, when you showed us your route for resource collections, was there a reason why you only returned a list of URLs and you didn't return the data that accompanied the URLs? So for example, your students, why did you send only the URLs and not the first name and last name for all the students in the list? Is there a reason why you do that?
Yes, there's a reason. So a lot of people do what you say, and it's perfectly fine. But if you want to take advantage of caching, then it's best that you return a resource in only one way, right? So that's why my lists have URLs, and then the client can go get the URL, only so that I can optimize my caching.
Okay.
There's only one place where the students in this example are cached, and that's the individual URLs.
Okay, thank you.
Yep.
So I have two quick questions. First one is, do you support patch?
I don't, but you can.
You can. It's easy to add.
It's your choice, yes.
Yeah. And the second one is it possible to specify a partial consumption of the URL? So in other words, if your resource lives 4 or 5 path components deep, you can say, I can consume the first 2 path components, and then that would return an object that it would know how to consume the last 3 components?
There's a way in Flask to say, from this point on, put everything that's to the right in one argument. It's called path. Okay. So you get the path in your route as an argument, and then you can parse it and do whatever you need with it. Yes.
Hi. Earlier you showed the login required decorator, and you also showed that if you needed to decorate all your routes, then you can put that in a before request. Mm-hmm. What's the normal pattern if you have to do that for every route except for the login route? Because you don't want the login route to
very
redirect.
Good question. So this is in the example code. I didn't have time to talk about other things that Flask does. So Flask supports blueprints. With blueprints, you can create groups of routes that are, that have some logical, meaning together. So if you have 2 blueprints, you can have one for your routes and one for this one route that returns a token, for example. If they're separate, then you can have different before requests for each.
Okay, cool.
Mm-hmm.
So I noticed, obviously this is pretty much just example code, but a lot of what you were doing in your decorators, like especially with like rate limiting or cache, like turning off caching, mm-hmm. is the kind of thing that you'd often want in either deploy time configuration or even runtime configuration. I was wondering if you could maybe elaborate a little bit on any experience you've had in that kind of area. Like, for instance, maybe you want to I mean, with what you were showing, like if you were to say want to turn off rate limiting in dev, right? That's a code change for that environment as opposed to just a configuration change. So I was wondering if you could perhaps elaborate a little bit towards that.
That's a good point. I didn't show configuration. I hard-coded all my parameters here. But Flask has a configuration object, and you can, it's very simple. It's key value list. So you can set any configuration that you want in the configuration object and use it from there. Does that answer your question? You don't have to do it like I did here, which is, you know,
I was thinking even towards like.
I can hear you.
Sorry, I was thinking even towards like sysadmin tools, like actual like runtime management of the system, as opposed to just. Anyway,
so
it's all right.
If you prefer to do it outside of this, it's not a problem. But
so we saw like the ETag Decorator, the login required, the Paginate. It seems to me like there's a lot of decorators out there. So it's like you removed some of them from slide to slide, but in the end there was like a student.query, and in my imagination it was like 10 decorators before that. And I was wondering if you, it's a critique of course, but I was wondering if you know this library RESTful, Flask RESTful, and is there a reason you chose to use like specifically decorators and not something which is like made for making REST requests?
I think Flask is made to make RESTful APIs. The way you express routes is very RESTful, in my opinion. I do like Flask RESTful, so don't assume that because I'm not using it here, I don't like it. I do like it. I even blogged about it. But
why? Why don't you like it?
Why I do like it?
I mean, what's the main reason you don't like Flask RESTful?
I like decorators. So this is
all right.
This is very readable. I don't think Flask RESTful fights with decorators. You can really have both. So, for example, Flask RESTful has a very nice marshalling module that you can use instead of my homegrown way to generate a JSON representation. If you have a really big resource, then it might be interesting to use Flask RESTful for that. For the routing, I really like Flask alone. I prefer that to the class-based structure from Flask RESTful. But it's a preference. So, as I said at the beginning, you don't have to believe me or like what I say. I mean, the nice thing about Flask is that you and I both can do what we like, and it tolerates us both. So.
Thank you.
Mm-hmm.
Thank you.
First, thank you for a great talk.
Mm-hmm.
So my question, I don't remember all the details for your Pagination Decorator. Mm-hmm. So perhaps my question will be malformed, but if I recall correctly, you first return all of the query results, but you only actually end up returning, concatenated list of the actual results.
No. That's not how it works.
Okay.
The function returns a query. This is a query that didn't run yet, so it didn't, you didn't use any resources yet. It's just a query that's still to be run. You prepare the query, and then you return it. The decorator gets that, and instead of running it the normal way, it runs it through this paginate function that comes with Flask SQL Alchemy. And that gets only the one page that the client wants.
Okay, great.
So
thank you very much.
There's no waste.
Thank you.
Yep. Okay, I think we're done. Thank you.